Hi everyone, this is the progress presentation of OpenARK Digital Twin. There are 4 people inside our team. All of us are MH students study electrical engineering and computer science. The problem we are tackling with is called digital twin. The definition of digital twin is to create a virtual representation of its physical counterpart. We will be given the CAD model of the object that we are going to create its digital twin. So based on that definition, we can further define our problem as 3D object detection and 6D pose estimation to know where is the object and also what is the pose of this object. This project is working with Siemens. We will use the model provided by Siemens. You can see below picture of the provided model. So we will design the algorithm that can perform pose estimation on those given model. And there are certain requirements we have to meet. The first one is the error rate should be within 5 millimeters. As you can see, the provided model are so tiny. Also, we have to define the algorithm that take RGB only as input, and also can perform pose estimation in real time. To be real time, we have the runtime speed of our algorithm should be up to 30 frames per second.
So our final goal for this project is to have 6D pose estimation on real dataset with error less than 5 millimeters. And then the goals for this semester is to generate 3D synthetic dataset from the given CAD model, and then also develop a team code base based on PyTorch Lightning, extending from the current dense fusion code base that supports detection from RGBD. And then we also want to apply the current methods to our costume datasets. So for our stretch goals, we want to definitely see improvements on performance and also achieve the state-of-art accuracy. And then we also want to see results on low-resolution RGB-only inputs. So for the challenges, RGB-only methods do not have good accuracies compared to RGBD inputs. And then we also want to bridge the gap between synthetic dataset and real-world dataset because it's expensive to develop a real-world dataset. And then we might not be able to guarantee a real-time detection and accuracy at the same time because there's a trade-off between performance like frame per second versus accuracy. Last but not least, we have a tiny object, it's 5 millimeters, that requires high precision, but our current existing depth camera might not be able to achieve a millimeter accuracy.
We have read lots of related papers in this field. For 6D pose estimation with RGBD data as input, we have reviewed the dense fusion, pose RBPF, and FFB6D methods. The architecture of dense fusion is presented on the right. It consumes RGB and point cloud data separately at first, and then fills their features to fit the pose predictor network. For RGBD inputs, we read repose methods. Also, the method for generating synthetic dataset we refer to is Falling Things paper. This paper also proposed an Unreal Engine 4 plugin for researchers to generate synthetic data. Also, we have reviewed the YCB video, line mode, and occlusion line mode dataset, which are baseline dataset in this field. Our next step is first improving algorithm based on dense fusion, like changing the rotation representation, and we will do more literature review on RGB-only methods because of the requirement of Siemens. Also, we are going to generate a synthetic dataset of CAD models by the plugin in Unreal Engine 4 I have just mentioned.
Now I'm going to talk about our progress. Currently, we are focusing on prior works implementation and data preparation. We've already tested dense fusion's performance on YCB videos and line mod, and we are now working on the implementation of pose RBPF. For data preparation, we've set up an Unreal Engine 4 project for synthetic data generation, following NVIDIA's Falling Things project's instruction, and it can generate some static samples with RGBD and 3D pose labels. What's more, we also 3D printed some CAD models that Siemens sent us for real-world data generation. That's all. Thank you for watching.